Hello everyone. Today we are going to understand on how we are going to perform hyperparameter tuning in real world scenario or real world project, and we will explore those things in a better way. Let us start with our topic today. Let us understand on how our HP tuning is getting used in case of regression, and I am going to show you two different methods here. One is grid search CV and random search CV. The Bayesian one, I need some time to analyze and create the code. I will share it during our next video. So let us understand on how my grid search CV and random search CV works. We know the process, guys, right? We have to import the libraries, so we did it. Then here I am considering car price prediction, data set, and I'm initializing my data set, or like I'm reading my CSV. Then this is my head, and if you see the head, my head contains the make. That means what is the brand of the car, right? Make, then model. What is the model? They have just given model B, model C, just because these are the test data when we are using, right? These are not the the actual real-time data. These are the data which the companies or which we are getting by web scraping, and we are using different methods on getting the data, right? So, and these are the year of make, like on which year this manufacturing happened, then engine size, mileage, right? Then fuel type, transmission, and price. It's a simple data set. However, let us understand the info part. So info part, we can see that we have 1,000 rows present, and we do not have any null values because all are filled up. And we have different type of data types: object, int, and float. Now I'm getting my descriptive statistics, and here I have shown you. Usually I used to take all my numeric data, right? However, if you want to use, or if you want to include all, then this is the method. You can use include equal to all, right? And with that, we can be able to see that, okay, whichever we have, numeric, we are getting the values. Which we do not have numeric, we are getting NA. That means these are my object type, and we will not be able to see any descriptive statistics for that. And I can check whether I have any duplicates or not. So with that, I do not have any duplicates because I'm getting the good size or the good amount of data, whatever it is resembling with my original data. Then this is my way of finding whether I have null values or not present. This is my data dot shape, and these are my final columns. Now I am trying to understand the bar plot between, because here my target column is price, right? Because we're predicting the price of the car. So I am understanding the different bar plots as related to or as compared to the price. I am understanding how my transmission is getting related to my price. So I have drawn my bar plot because this is my EDA part, and I'm just trying to understand, okay, I have manual type and automatic type, and both are almost same. Like almost they both are getting released with the same price range, almost same price range. Then now I can understand, okay, how my make and my price are getting related. So you can see, and I have used the color palette, guys. That's why you're able to see different color combinations. And this is just a warning, guys. Don't worry about it. This is just a warning. Whenever any new versions are getting released, they will try to are going to be released. They will give you the warning that will be deprecated, or this method is going to be deprecated during your next release and all. So don't worry about it. Now we will see that, okay, we have Honda Ford, BMW, Audi and Toyota. These are my 5 brands of cars present. However, you can see the maximum sale or the maximum price is coming for Honda. Then the next maximum is for Ford, then BMW, then Audi, then Toyota. Then we have model and price. Now I want to see which model is having more price as compared to the others. So this is the one. So you can see my model D is having almost similar range with model C and model B. And however, I can see all models people are purchasing and all are coming in good price range. Then I am trying to get the count plot of all. This is my count plot for make. Okay, so I can see Ford is getting like people are purchasing Ford brand more, then Audi, then Toyota, then Honda. Then after that BMW. Then model, my model again, the count is more for model B, then model C, then model A, then model D, then model E. Then fuel type. Fuel type, let me see, we have 3 types I guess. Yeah, so petrol type, electric fuel type, then EDZ. So if you see, the diesel cars are getting purchased more. This is the general thing, guys. This is the EDA part which you are understanding the different behaviors of the features, right? And this is most important. This is the part of our life cycle, correct? Machine learning life cycle. Then I am understanding my transmission, how many transmissions are present. We have manual and automatic. However, the manual cars are getting purchased more here. If this is a bar or the count plot. Then I am understanding my difference or my relation between fuel type and price. Let's see that. So if you see my fuel type I have petrol, electric fuel type, then diesel, right? So almost all are having getting purchased regularly and all are having good range, like $25,000 I believe. Then we can understand scatter plot, right? Scatter plot is the one where we can find out the outliers, right? Scatter plot and box plot, these are the tools. So this is the one, and I can see that okay, the ranges or the prices are almost like the blue and red dots or the orange dots are having in a good numbers and with equal distributions. There is no high or no low in between them. And this is the make price, and I am trying to understand the hue as per fuel type. And how many fuel types I have, guys? I have my petrol, electric and diesel. And this is how my data is getting scattered for each. So you can see for Honda, I am able to see, because here you can see the points are overlapped with each other. So sometimes as you are watching with 2D, right, you are seeing in a 2D view. If you see in 3D view, you should be able to understand the pattern on how those values are, or which fuel type values are coming more. However, in this also we can see that all the 3 types of fuel type or all the 3 colors are significantly present in all the type of categories of make. Then engine size with price and the hue is fuel type here. So if I can see even here also predominantly the points are present, and even for model and price and transmission, this is how it's coming up. Predominantly the points are there. Then we have transmission and price according to your fuel type. So this is how it's coming up, right? And you can see here fuel type, then price and transmission. So this is how it's coming up. Then finally after that, what I am trying to do, I am converting them to like whatever my categorical variables are present. I am going to perform some feature engineering there, and I am trying to convert them to numeric. So here I have converted to my numeric using ordinal encoder. Then this is my head finally. So you can see now my head is containing all my numeric. Here we will see how year is getting correlated from the correlation matrix. So now I'm getting my correlation matrix, and if you see my correlation matrix, we'll see that you can see we will directly come down to the price, and in this section we can be able to see, because that is our target variable and we want to know how my each and every variable is getting related there. So we can see that price with make is not having good correlation. Model, it is diminished, it is not needed. And year, it has some good correlation. Engine size, it has good correlation. Mileage, it has correlation but negatively. Then fuel type, it is not having good correlation. Transmission, it is not having any good correlation. So we understood that year, engine size and my mileage is having some amount of correlation with my car price. Now let us see that box plot, whether we have or we can collect our outliers. Guys, I have already told you some techniques. If you will find out outliers, the next step is you can use G-score. And from this, right, from this box plot, suppose you are thinking, take an example that you are getting the you're doubting that those can be outliers. So you can take engine size. This is the engine size, right? So you can take engine size and you can just apply G-score method there, and you can see any outliers are present. Outliers means what, guys? Any extreme outliers you need to consider. If your ranges are coming 5 and 10 and 20 like that, you should know. If my range is coming 5 and another is coming at 50, right, then there is a high gap. You need to consider it. You need to think of reconsidering those values in your dataset. That might violate your dataset. Then we can understand the trend by using reg plot. This is my reg plot, and whatever we got our correlation metrics or the correlation variables, we are performing the reg plots on them. Year also, again, I can see we saw the positiveness, right? So the same thing I'm able to see here. Then mileage, we saw the negative correlation, so the same thing I'm able to see here. So we found everything here. We completed all our analysis. Now we are performing elastic net regression here and the grid search CV at the same time. So these are my things I am passing here. So I am passing my model selection, and I already told you grid search CV is present in my model selection, just the way we have in our train test split. Then linear model, inside linear model I have elastic net. Then inside pre-processing I have standard Sklearn. I am just creating a pipeline, because for elastic net it is always better to use your standardized scaling technique before passing or before training a model. I am applying a pipeline here. This is a new technique. Understand this. So is again a Sklearn and pipeline module. Then these are my metrics I have used. So let me run this. Now I can define my independent variable, then my dependent variable. This is my independent X, this is my dependent Y. I can get my X train, X test, Y train, Y test. Just I am passing this. This is our regular method, right? Now we will create a pipeline. So in the pipeline, I am using my scaler, and in that scaler, what I told you guys in case of pipeline, it should be a key and value pair, right? So in that, it's going to be a combination of tuples, and you need to pass key or as a name of the variable. So here I am passing as a scalar, and I'm telling I'm going to use as a standard scalar my model. Then I'm telling my elastic, and I'm using my elastic net. Makes that's nothing but a number of iterations. And this is a sweet spot. 5000 is a sweet spot for that. Then what is the next step, guys? We have to define param grid. That's what we understood during our theoretical part, right? We are understanding the same through this. So param grid, inside the param grid, I am using elastic alpha, and these are the different ranges I want to evaluate, right? And what is my elastic alpha? That's going to control your overall strength of your regularization penalty. Then elastic L1 ratio. So Elastic L1 ratio is the one which is going to be giving the balance between the L1 and L2, and these are the different values. And the value should be between 0 to 1, just for your understanding. So we have defined our param grid. Now we can implement or we can apply our grid search CV, right? Grid search CV, again, it's algorithm, right? So we can get our object, and this is my grid search CV. Inside that, what I have told you guys, we have to pass estimator, and inside that estimator I am passing my elastic pipe, which I have defined already. Then param grid equal to param grid CV. I have already told you during our theoretical part. I have using 5 cross validation of 5 folds. Scoring, I am telling negative, mean, absolute error. That means I have given few points here. Why negative? That means MA is a loss, right? I am telling that I am going to use MAE for my future, and higher negative MAE means better model, lower negative MAE means worse model. And N jobs, I told you, right, for parallel processing of your CPU or for the better core capability, we are using -1 by default. That's it. Once you are using grid, then after that we are fitting our model by using training data. We got one error. Let's see what is that. Name param grid is not defined. Okay, we need to use. Okay, I need to run this. Then after that I need to run this. Done. Now, what is the next step? We understood. We can get our best params and best score, and we can print it. So this is what so it is telling that your alpha best parameters for alpha should be 10, and your L1 ratio should be 1, and best score what we got, or the MA, mean absolute error, is 1618. That is all. So what we got. Now I am getting my score, or I am applying my evaluation matrix. So this is how I am predicting my model, right? So I'm assigning my best model, and inside that best model I am using my best estimator. Again, that is one more parameter. So what are the parameters we understood? We understood best params, best score, then best estimator, and I am getting my best model and predicting my test data. Then same method, we are using my mean absolute error. MAE or mean absolute error is going to take actual data, predicted data. Similarly, RMSE, actual data, predicted data. R2 score, actual data, predicted data. That's it. We are getting our output. And this is my MAE, this is my RMSE, and this is my R2 score. R2 score I am getting 82%, which is good. And this is my shape of the Y predicted, which we got, because we have used 20% of my data, right? Now, we will see what is the price, what is the final price which we are getting. So, the final price is going to be, we have the actual, right? So, that actual is going to be the, the final one is going to be the difference. Whatever MA we got, right? Whatever MA we got, that MA we are going to, you can see that price minus MA, that's going to be my final car price. So that is how we can tell customers, okay, this is going to be your final price. That's it, guys. So this is how we can predict our car price, final price. And we will see how my random search CV is working. Similar fashion. So for random search CV, again I have used the same method. However, I'll straight down go to the part where I wanted to show the random search CV. So this is how we can pass random search CV, guys. Sklearn.model selection, import train test split, randomized search CV is the one. Same thing. I have used the same thing, only I'll just show you the process. Okay. We'll come here. So this is my pipeline. Already we have seen during our grid search CV, this is param distributions. This is my param distributions, model alpha, model L1 ratio. This is how we can use. And here I have used log space because it's going to take random samples. Remember we discussed random samples. It's going to take the space between -4 and 2. Similarly, here it is going to take the space between 0 and 1, and till 50 range it is going to take. Then This is how we can pass it. Random search is the object and RandomizedSearchCV is the algo I'm using. Estimator I'm using pipeline, param distributions, n iterations, try 30 random combinations it's going to use. N iterations. We already saw this during our theoretical part, right? Then scoring. We are using scoring, and CV we are using 5. Random state I told you we are going to pass 42. Verbose it's going to, verbose is again going to give you the status of each internally. Then n jobs, right? So these are the different parameters, and after that I'm fitting my model. Then after that what is happening? You can see my verbose, it is giving me fitting 5 holes for each of 30 candidates, totaling 150 fits. That means it is multiplying 5 into 30, right? That means 150 combinations of output it is giving internally. Then after that, what we are trying to do, we are getting my best params, we are getting my best score. The best params it is telling, it's there in 0.28 or 0.29 people. Then the alpha value we are getting, this is the L1 ratio. This my alpha value is getting 0.03, and the cross validated MA is nothing but your 1619. That's it. Here, if you'll see, guys, we are getting negative, but however, I'm just taking negative of this score, so it's getting positive. So I'm evaluating on my test set. No, this is my Y predicted. I'm taking my random search.predict, and these are my scores. That's it. That's the process. So, what is the understanding we found it here? We are going to use my estimator, right? Because again, that's an algorithm. So before passing, you have to create a param grid or param distribution. Inside that, you have to create a hyperparameter list or the hyperparameter combination dictionary. Then you have to use everything in the RandomizedSearchCV algo or my GridSearchCV algo. That's it. So we will meet during our next video, guys. Thank you. Well, that is all for now. We will start with classification algorithms of supervised learning during our next videos, upcoming videos, and those are again another aspect of important concepts. So please start subscribing if you really like the content. While subscribing, do not forget to hit the bell icon so that you will not miss the latest updates. Like, share your comments, share your feedback, and share this channel link to all your friends and near ones. See you till the next time. Bye. Thank you.